two types of triangles. The first one is a 45, 45, 90 triangle. And the basic rule is that both of the sides are congruent, and that whenever you're going to find the hypotenuse, it's always whatever the length is, and then you just add radical 2.
45, 45, 90 could also be like an isosceles triangle theorem. They could be the same because if the two sides are the same, like that, then the two angles have to be the same. So this has to be the same as that. And this can be like 90 degrees. It can work out sometimes, so two legs are congruent. So this is a 30, 60, 90 triangle. One of the angles is 30 degrees, one of them is 60 degrees, one of them is 90. And so if you have like x, which is across from the 30, then you can find the rest of the sides. The hypotenuse is always twice as much as x, and across from the 60 is always x radical 3. So to find that, if you have one of these, you can find any of the side lengths. This is a 45, 45, 90 triangle, and we're going to find the length of this, which is an x. This is 20, so what you want to do is divide it by 2, so you get 10, and then since it's a 20 and no radical next to it, you add radical 2. So the answer is 10 radical 2. Sweat.
Okay, so this is a 30, 60, 90 triangle, which means to solve for x, the rule for the 30, 60, 90 triangle is you divide the hypotenuse by 2. So x would equal 10, because 20 divided by 2 is 10. And then to solve for y, the rule is you put the radical 3 for whatever this is. So it says x is 10, y equals 10 radical 3.
Alright, this is a 30, 60, 90 triangle, and we have a side length of 5 radical 3. So to find the rest of the side lengths, you would simply take the 5, and then you'd make that x, so x would equal 5, and then the y you would double the 5 and make 10. So x equals 5 and y equals 10.
Okay, so we have an equilateral triangle here, and in order to solve it, we have to divide it, so it's like two equal triangles. So this will be 90 that's 90 degrees. And so if each angle is 60 degrees in a regular triangle, to add up to 180, then this is still going to be 60, and this will be 30. So we have a 30, 60, 90 triangle. And if this, I'm going to erase this. If this whole side is 8, then that means this side will only be 4. So to find x would have to equal 4 radical 3. 4 radical 3, because it's a 30, 60, 90 triangle. And yeah, that's how you solve it. Woo! Okay, so for extra credit, we're going to find the area. So there's A for area. So to find area of the triangle, it's 1/2 base times height. So it would be 1/2 base times height. So the base is 8, and the height is 4 radical 3, because that's what we solved for x. So times 4 radical 3. So we'll just take half of 8, which is 4, and then multiply it times 4 radical 3. What do you do after that?
It's 16 radical 3.
Okay, so 4 times 4 radical 3 equals 16 radical 3. And that is the area.
Alright, we have a 45, 45, 90 triangle, and we had the hypotenuse of 30 radical 2. So to find the sides, all you're going to do is take away the radical 2, and then you just leave the answer, which would be 30. So x would equal 30. Our real world example. example is we're going to find all the lengths of this window. So to start off, I'll measure the side. Alright, it looks like we got 20 inches right here. Alright, so, and this is 20 inches also. So, that's going to be our real example, and we're going to come to the whiteboard.
Okay, there's our square. So if it's 20 inches by 20, that means it's an equilateral square. So if we were to cut it into half.
Equilateral square?
Yeah.
The square, the side lengths are all the same. Extra credit.
Okay, so if we were to cut it in a triangle, this would be 90 degrees, 90 degrees. And so if this were 90 and you cut it in half, that means it'd be 45, which means it's a 45 degree triangle. So if this is 20 and this is 20, then this, I'll mark an H for the hypotenuse. The hypotenuse is going to equal 20
Radical 2.
radical 2. Because in a 45, 90 triangle, the hypotenuse is just radical 2, or whatever the other side lengths are. So that is our real world example. Woo!
Swag!